welcome to the Auto.AI and OSIS 5 conferences here in Berlin. My name is Maria and I'm standing here with Chuck Brokish. Hello and welcome.
Thank you.
Can you briefly introduce yourself and your company and what you're doing there?
I'm Chuck Brokish, Director of Automotive Business Development at Green Hills. Green Hills is a company that's been around for about 36 years. We started as a compiler company, software C code, ADA compiling. Since then have grown for in the areas of development tools, debug tools, and certainly lead the market in those spaces, especially in the compiler. About 25 years ago, we got into creating operating systems, and we created an operating system at Green Hills that is called the Integrity Operating System. That operating system is the highest certified operating system in the world for both security as well as safety.
What fascinates you about autonomous driving and what are your experiences? Have you ever been driven in an autonomous car?
I have been driven in an autonomous car in a very geo-fenced area, more following breadcrumbs. I've had the opportunity to ride in cars that have actually had an aggressive mode where they drive not like the Google cars in Silicon Valley, but I actually drive a well-known and safe route more aggressively. And it is interesting to see what is possible with a vehicle if you allow it to do so. Autonomous is a very interesting field in that we have a long way to go before we hit mass production and the ability to go geographically unlimited, but I think we are certainly getting closer to having geo-fenced capability.
You also have like autonomous car electronics domain is like the topic of your speech tomorrow, or of your case study. Can you explain that a bit? What is it about?
There is so much software that goes into the development of autonomous cars that we're leveraging research. We as an industry are leveraging research that's been done through universities, that's done through corporate R&D departments, and there's millions and hundreds of millions of lines of code that have been created. With all of this code that's been created, it's primarily been created as proof of concept, using a lot of open source code, things that have been developed to prove a concept, but not necessarily with safety and security in mind. And the aspect of going from a proof of concept to a production-ready vehicle has to take in consideration how do we implement safety and security. At Green Hills, we've stated all along, and the industry agrees as well, that safety and security are not items that can be left for after the fact. They can't be an add-on late in the stage, so they have to be designed from the ground up. So what we are doing is trying to work on a solution of being able to leverage the mass production of software that has been developed to this point for proof of concept, while still enabling the high security capabilities and high safety capabilities that we have leveraged within our operating system through military, aerospace, medical, industrial spaces, and of course automotive as well. So we need to separate the system to the critical components, run them in our operating system, and then leverage the non-critical components of open source on top of that.
Like you said, major is like one of the major challenges. So how can we build a car that is really safe and secure so nothing happens with it, like when it's driving, or that also somebody from the outside can't make an accident with people inside of it?
That is by far the biggest challenge we have going forward. Safety in that there are challenges in trying to assess what are all the possible scenarios of what a vehicle could get in, and how do we guarantee that it's safe in every scenario. This part of why I state that I think they will be geo-fenced for a while yet, where they operate in a very well-contained environment. But the security aspects is another concern in itself, in that we need to start from the very core internal the lowest level of software that's inside of the device, and start building on a secure operating system and build our way up. The security of, or the lack thereof, I should say, with open source today is a sincere concern. So our belief is that we need to start with that certified secure operating system at the low level, and then make sure that we use isolation. guaranteed freedom from interference from every function that
Yeah.
occurs within the vehicle, and make sure that we run them independently, and assure that all of the tasks that are functionally safe and functionally secure get operated on, and do execute in a timely, deterministic manner, without interference from untrusted code.
It's a holistic approach, but also the systems run individually.
Yes. So absolutely making sure that we run the critical components, and now we have to segregate the system. And this is really what it comes down to, is separating the tasks that are being performed, understanding what tasks are critical, which tasks are non-critical, critical for safety as well as security, and making sure that they are run in a timely manner, but making sure then that we can understand the non-critical tasks and allow them to run in the background, and make sure that by no means do they ever interfere with the critical tasks.
Like we said, safety and security, two major challenges. What other challenges are we facing?
I think the other challenges that we will be facing in this space, frankly, are going to be testability.
Okay.
And that is, how safe does the vehicle need to be?
Okay.
If we look at some of the numbers of what we've got, and I'll use the U.S. as an example, the U.S. has 1.12 fatalities per 100 million miles driven. So that is basically 90 million miles between fatalities.
Yeah.
It's actually quite a ways if you think about it, 90 million miles. Now, that's not that time between accidents, but that's the time between fatalities. Now, if we look at how safe does an autonomous vehicle need to be, if I asked you, how safe should it be? You'd look...
Very safe.
Okay, very safe.
So,
many people say, well, it should be at least as safe as the average driver.
yes.
Okay.
If you start from there, sure.
So it should be as safe as the average driver. Well, the average driver, when we look at that one death per 90 million miles driven, that includes the teenagers who just got their licenses and hot rodding. That includes the people who are texting and driving.
Yep.
That includes the drunk drivers.
Yep.
That includes the people who are tired and sleeping while driving. So that 90 million miles could actually be significantly higher if we didn't have drunk, texting, speeding,
Old
sleepers,
people, yeah.
in the vehicle. So the average that we're looking at, if we say this autonomous vehicle is going to be as safe as the average driver, that means it's going to include all of those those problematic drivers.
Yes.
So in fact, what I'd like to say is the autonomous car should be as safe as a good driver.
Yeah.
Now, a good driver is going to have a much better number than that yet. So in order to prove that, we have to get literally billions of miles put on autonomous cars. And so the big challenge, frankly, is going to be, how do we get billions of miles put on these cars to prove that without using humans as crash dummies? Because right now we've seen some examples, including Tempe, Arizona, where software fails and the humans become the crash dummies.
Yeah, this is not something we want, of course not.
No.
So, but with all that in mind and the major issues as safety and security being there, how can all the manufacturers, tier ones, and car sellers and so on really get people to get into an autonomous car or buy one? So how can people really accept
and trust.
And trust, really trust. You said it, really trust autonomous driving and autonomous cars. So what needs to be done from your perspective?
Well, for one thing, we cannot overlook the accidents that have occurred. There has been a tendency, I think, in too many cases to say, oh, yeah, somebody died in an autonomous vehicle, but it's proof of concept and it happens. We need to take these accidents that have occurred very seriously. We need to make sure that we fix it. We need to do more in simulation and modeling and make sure that more is done within simulation so that we don't use the real world as our crash dummy. If you look at functional safety and what has been done, functional safety for years, we've been able to prove from a 5-star rating on a vehicle, we've been able to prove that vehicles are safe through testing in a very enclosed environment where we can make sure the airbags, the anti-lock brakes work, and we can put crash dummies inside of the vehicle. And to this point, if a functional safety feature fails, it's the occupant of the vehicle
Yep.
that ends up being the victim. So if you decide to spend less money and buy a cheaper vehicle that doesn't have the functional safety capabilities in your vehicle,
Yeah.
you're putting yourself and your passengers at risk. If we create an autonomous vehicle that doesn't have the proper level of functional safety in it, it's not just the passengers of that vehicle, because that vehicle is operating in an environment
Yeah.
where the entire environment is now the crash dummy. And
Wow.
so that's frightening. So
Yeah.
we have to do far more than we have done in the past to prove the functional safety aspect of it.
Yeah.
And that means lots of simulation. So we do have the ability. There are companies here that are talking about simulation, real world simulation, synthesized inputs as well as real world inputs. But we need to do that and prove that we can get as close as possible to those billions of miles that are driven, every scenario imaginable.
Yeah.
Modifying all of the inputs and saying, what happens if I lose this sensor? What happens if the light changes? What happens if the road gets slippery? And really doing a very diverse set of cases and to prove that it's safe in all conditions. And once that is proven, then people will start having more confidence in it.
Will there ever be a safe car, like 100% safe autonomous car? Because you have the AI, you have all the scenarios, the car is learning what is a tree, what is a rock, these are the pedestrians, and so on and so on. So will there be a time when we have like 100% safe car?
That is a very difficult question. I think it depends, frankly, on the use case.
Okay.
If we have a geofenced area where the environment is very well known, let's think of the simplest case where a vehicle follows a well-defined trail
Yep.
where perhaps there is no access to it. You've got a fence on both sides.
Yep.
And let's think about the simple case of someone riding a train,
Yep.
subway or tram
Yeah.
that is on rails. You would, 100 years ago, nobody would have thought of getting on a train that didn't have an engineer on it.
That's true, yeah.
Okay, but now you think nothing of getting on a tram at an airport and going to the next stop. The train takes its route, stops, opens the door. It doesn't speed through the end of the track or do anything. We've learned to trust that.
Yeah.
It's a very controlled environment. So if we start looking at scenarios where a vehicle can run in a known course with limited obstacles in its way, perhaps there's a crosswalk, perhaps there's other things that are in there, but we have the ability to recognize all of the obstacles and be able to progress, we will gain trust in that vehicle. Then we take it to a point where a larger audience.
Yeah.
I do think that there's a tremendous opportunity in Chicago and New York and other large cities to be able to use autonomous in a very tightly geofenced area, even though there are more obstacles, because we have mapping down to the centimeter level of
true.
accurate maps. We have the ability to recognize pedestrians, other cars in the area. There will likely still be some accidents. More likely, I suspect, by human drivers who get more aggressive than the autonomous vehicle. But I think that is where we'll start to see it. Now, I live out in the country. I don't expect to see autonomous vehicles on my road anytime soon. I live in the country on a road that's barely 2 lanes wide that has no lines on it.
Okay.
and has lots of wildlife.
Yes.
So for an autonomous vehicle to navigate its way down that path, past other cars on a narrow road with wildlife on it, is well beyond where we're at now.
Okay.
But I think in a well geofenced area where we can get, frankly, more return on autonomous vehicles, we will see that come in. So you start in a very controlled environment where there is no other traffic and obstacles are very minimal. Then we grow that to a very well mapped area where there maybe are more obstacles, but where the payback of having autonomous becomes tremendous if we don't have to have our own vehicle, and we don't have to have a cab driver in all of the cabs in New York because they're autonomous vehicles. Those types of scenarios are steps along the way to getting to where we need to be. 100% safe is going to be difficult. I do believe that we are going to need to raise the bar on what those standards are on safety standards. Our software runs in military and aerospace applications. So DO 178 is a standard that we have to hit for aircraft. That is far beyond what we have within automotive today for ASIL D safety. That has to be certified outside of our company, has to be certified by the FAA to be proven that it is at safety level. I think that we need to get to that same level of certification and provability within automotive, because autonomous cars, just like an aircraft, if it fails, could cause mass casualty. So, and last I checked, autonomous cars are not going to stay 1,000 feet away from each other.
No.
So we have to have at least that same level of safety that we put on aircraft within autonomous cars. And so I think the industry needs to work on what is that safety level? How do we implement it? Who certifies it? We can't have self-certification. It has to be independent external certification, and make sure that we've got it to a level that is at or above what we have in aerospace right now. And that's going to be a hindrance. It won't be simple and it won't be cheap, but that is when people will get...
And trust, really.
Trust. You trust when you get on a plane and the pilot puts it on autopilot. We don't have to worry about it dumping us all into the ocean. We need to get that same level of trust. Why do we have that level of trust on planes? Because of all of the testing and certification it's gone through. That will be what enables us to get to that level of trust in autonomous.
With all the autonomous driving we are talking about, will there be fun of driving like we have it like right now? All the manufacturers are saying, okay, if you drive, you see them in the commercials, they're driving around lanes and so on with a nice view and so on. Will there be fun of driving anymore?
I think there will still be fun of driving. The question is that fun on the regular road anymore?
Okay.
Someone gave an analogy a while back to me of, everybody used to drive horses down the road, ride horses down the road, or drive the horse with the wagon. You don't see that anymore. Horses now are off the roads. You can go out and ride horses in the pasture at a track or wherever you want to be able to do on a course, but it's not on the road anymore. If we get to where we have highways become autonomous vehicles only, then that thrill of driving, unfortunately, will have to occur on another road. Now, that might be simply a back road like I live on, because the autonomous cars won't be there, but it might not be that we can take our manually driven car onto the regular interstates, because those become autonomous only. I do believe that we will have areas that become autonomous only, because humans will mess up autonomous vehicles if we operate in the same space. But I think the thrill of driving, given the fact that I don't think that we will be able to go across Europe through all terrain in all weather with an autonomous vehicle, I think there will still be roads where manually driving is not only required, but also certainly going to be invited for those who love the pleasure of driving.
Thank you very much, Chuck, for this chat, and I hope you enjoy the rest of the conference.
You're welcome. Thank you.
Thank you.